reaction, we use the formula R equals to KQ minus F. Now, in this equation, from the stiffness matrix, we are going to use the rows which correspond to the supports only. So, which means that at node 2, there will be no reactions since there is no support. So, R3 and R4 have to be eliminated from this stiffness matrix. Only the two rows corresponding to R3 and R4. So once we eliminate, we get this matrix here that we see. This is the one. So we have only 4 rows and 6 columns. Now to get R1, so it will be R1 equals to K1, which represents the first row of the stiffness matrix, into the displacement vector minus F1. Okay, so K1 is this one which is indicated in this arrow here. So this multiplied by the column vector. So we get minus 1 into minus 0.57 multiplied by the common term 28 into 10 to the power 3 minus F1. So I will write down here F1, F2, F3, F4, F5, F6. So minus F1, in which F1 is 0. So this is 15.96 kilonewton. Next, we go to R2. As we see, all the numbers are 0. So R2 will be 0. Next is R5. So for R5, we have minus 0.64 into minus 0.57 plus 0.48 into minus 1.95. This entire thing multiplied by 28 into 10 to the power 3. Now F5 again is 0. And this is minus 15.96 kilonewton. And the last reaction, R6 is given by 0.48 into minus 0.57 minus 0.36 into minus 1.95 into 28 into 10 to the power 3. F6 is 0 and this is 12 kilonewton. So if I draw a free body diagram, we have 12 kilonewton here, node 1, node 2, node 3. So we have here R1 equals to 15.96 kilonewton. Similarly, R5 is minus 15.96 kilonewton. And R3 is, R6 is 12 kilonewton. So we see that there is equilibrium of the forces. Next, we are asked to find out the stresses, and the stresses are given by the formula so here substituting all these values. For element 1, we have Q1, Q2, Q3, Q4. We know that Q1, Q2 is 0 and Q3, Q4 was minus 0.57 and minus 1.95 respectively. Solving for this, we get 79.8 Newton per mm square. Now, to find the force in the member 1, okay, so we can say this is the internal force in member 1. We know that the force can be given by the stress into the area. So it is 79.8 multiplied by area is 200 mm square. So that is 15960 Newton. Moving on to element 2. So we have the same formula here. The direction cosines for element 2 were L was 0.8 and M was minus 0.6. So it is minus 0.8, 0.6, 0.8 minus 0.6. Multiplied by Q3, Q4, Q5, Q6. When multiplied, we obtain a value of 99.96 Newton per mm square, a negative sign. So the force in member 2 can be given as sigma 2 into A, which is 99.96 into 200, which is minus 19992 Newton. Okay, so this positive sign here indicates that this is a tensile force, and this negative sign here indicates that it is a compressive force. So this is the end of the problem where you found out the stress and the forces in the given truss members. Thank you.